Ever been on a job before sunrise, generators running, diesel in the air, and concrete trucks starting to stack up? And you're thinking, do we order the right mud? Is this mix going to hold up? Did I ask all the right questions in the pre-pour meeting? And if this thing goes sideways, am I going to know what to do? That's why we built Concrete Logic Academy. It's for concrete people who want to get better at the work, not theory, not recycled conference slides, stuff you can actually use on the job. Go to concreteschool.co and get free access while it's open. Again, that's concreteschool.co.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
And welcome to another episode of the Concrete Logic Podcast. And today I have Nick Karam, Business Development Manager at Xypex with me. And we're going to talk about crystalline waterproofing technology. I was, before we hit record, Nick and I were chatting and he's like asking me if I had heard of Xypex. And I kind of chuckled because I when I think of Xypex, I kind of think of Kleenex for some reason. I think, people don't say, hey, hand me that facial tissue over there. They say, hey, give me that Kleenex. And that's kind of how Xypex is with crystalline waterproofing, at least in my experience. We normally run across it in elevator pits, is what I was sharing with Nick. And they'd say, hey, we need Xypex for that. And I don't even think half the world knows, or the people that ask for it know what it actually is. So that's what we're going to talk about today.
Absolutely.
What is crystalline waterproofing? What do we mean by that? How it works in concrete? So Nick's going to help us out with that today. But before we get started, I always like to remind you guys how you can support the podcast. The first way and the easiest way is if you enjoyed the show, you want to share it with a colleague or coworker. So if you get something out of the show, share it. We're on every podcast platform. So all you got to do is look up Concrete Logic. It'll pop up. So that's the easiest thing you can do. The next thing you can do is if you go to the homepage of the podcast, that's concratelogicpodcast.com. There's two ways that you can get a hold of me. One is there's a navigation bar up at the top. If you click on Ask Seth, there's a little email form that'll pop up. And what I'm looking for there are guest or topic suggestions. So reach out to me. Let me know what you want to hear, what you want to learn about, who you want to hear from. That's one way you can get a hold of me. The second way is if you don't want to type it out and you just like to talk, like myself, I'd rather sit here, talk on the microphone than type a bunch of stuff out. So that's why I like the podcast platform. But anyways, if you like to do that and you just want to leave me a message, there's a microphone at the bottom right-hand corner of the same homepage. So you click on that and it'll record your message right over your computer, your phone, whatever you're using while you're on the website. The third way is to donate to the show. So if you go back to the homepage, the concratelogicpodcast.com homepage, there's a couple buttons there. There's a support button, and the support button's for companies that want to support the show, and then there's a donation button. So if you click on that donate button, a PayPal page pops up, and it says, hey, you can donate any amount, and then there's no set amounts. There's some suggested amounts there, but you can put any amount you want in there. Every bit helps. And today I want to thank Ken Tiffany. He's donated to the show. Appreciate that, Ken, very much. And he's also a supporter of the Academy. So don't forget about checking out the Academy. You can join the Academy right now. I think it's still free. If you go to concreteschool.co, I think we're around 70 or so members, maybe more. I haven't counted in a bit, but yeah, join that. Same kind of, we discuss the same kind of topics on there. It's in a more academic format. We got quizzes in there. You can take quizzes. And what we do is we track everybody's progress on the courses that they take and then provide you professional development hours if you need them, or you just want to learn and separate yourself from the rest of the herd out there, become a concrete specialist. That's what the Academy is for. So check out concreteschool.co. I think that's it, Nick. So we're going to talk about crystalline waterproofing technology. If you want to talk a little bit about who you are, what you do to get us started. Tell us why you're so smart about crystalline waterproofing, and then we'll roll on from there.
Yeah, so my career started after I graduated from The Ohio State University with a degree in structural engineering. I worked as a structural engineer for a while, for about 10 years in the suspended access industry. So I got a lot of experience there in construction, being a subcontractor on, major high-rise construction projects. So that was a great experience. Kind of got sick of it though, just being at my desk every day. And so I wanted kind of a change of pace, and I looked into more sales engineer roles where I can use my technical expertise, but also get out, travel, and see people and develop business. So I did that for a while in fiber reinforced concrete with a company called Becker. We did ceramic steel fibers. And then recently, earlier this year, I moved over to Xypex. Really cool product, really cool technology. And I cover the Midwest for Xypex. I support 3 sales folks throughout the Midwest of the country. And my role is really to educate engineers, on the product. Luckily, a lot of them know Xypex, like you said, that it is really like the Kleenex of crystalline. So a lot of engineers that work on water projects already know us, which is great for me. I do a little less education, just a little more help on their projects, where to use it, and just helping them with specifications and all that. So it's a nice role.
Yeah. Well, let's talk about that. What is a crystalline? What do we put it in the? Do we mix it up in our concrete before it gets to the job site? Do we apply it afterwards? Maybe it's some of both. Let's tell us a little bit more about that.
Yeah. So crystalline is used to really protect concrete, not only from water intrusion or extrusion, but also chemicals and sulfates and chlorides, things that really bust up your concrete over time. And so it's funny, I talk to some of my friends or something that aren't in construction. I say, I'm doing concrete waterproofing, and they're like, well, why do you need to waterproof concrete? It's a solid block of mass. And I'm like, well, okay, make a bowl out of concrete, fill it with water, and let's see if the water's still there, tomorrow. So a lot of people might not know that concrete's porous. It has capillaries. We use a lot of water in concrete to make it workable, right? To be able to place it in the forms, to be able to trowel it, to place and finish. And so a lot of that water is excess water of convenience. And when that water evaporates out of concrete, you're left with these porous capillaries, so if water can get out, it surely can get back in. So that's part of, why this product exists, is to protect the concrete. And it's unique in that it's not something that you add on top of the concrete, a layer or barrier like traditional surface membranes or liners that are very labor intensive, that can be susceptible to error, install error, pinholes, anything that you hit it with an excavator, anything that you damage that membrane, now your whole system's kind of damaged and you get delaminations and all that good stuff. Crystalline's a little different. It's integral to the concrete, and you can apply it in 2 ways, really as a coating for existing structures or as an admixture for new concrete structures.
Okay. So when we say we add it, well, it's an admixture. So when we add it, what are we adding? What does it look like, and how does it activate to do what it's supposed to do?
So the product is composed of typically an active ingredient. Most of them are proprietary chemicals. So it's Xypex has its own formula. Our next competitor might have their own formula, but it's proprietary chemicals, usually mineral based. So stuff you find in everyday life. It comes in a powder form, and it's mixed with either Portland cement or a little bit of sand. So the cement and the sand are more filler. And then there's also the active ingredient in there. And to get it into the concrete truck, you batch it. They come in water-soluble bags. At least our product comes in water-soluble bags. So you can add it directly to the truck with a little bit of water, even before the concrete's in there. And then you add the concrete, you mix it up for a good, 5 minutes, and all that chemical disperses now through the concrete, and your entire truckload there is Xypex treated now, or crystalline treated. And so how it works is that active chemical that you introduce into the concrete, it reacts with the byproducts of cement hydration, mostly calcium hydroxide, which is present in the concrete as it hardens, and then water. So we want water to be present because that's what activates that chemical along with the byproducts of cement hydration. And then you get actual crystals. They're long, thin, needle-like crystals that grow inside the concrete, inside all the pores and capillaries. They're resistant to hydrostatic pressure as well. So they're using a lot of tanks, wastewater treatment plants, etc. So it's integral to the concrete. It kind of changes the structure of the concrete itself. The great thing about it is it's can be reactivated, or it could self-heal. So if you get a new crack that forms down the line and that chemical's still in that concrete, it kind of lies dormant until water's present. So if you get a new crack and then water gets in there, that will reactivate the chemical, and then the crystals will grow and block any further water intrusion. So that's kind of a gist of how it works.
Uh-huh.
We actually started as a repair company. So back in 1969 is when we were founded, but we started as more of a coating system for existing structures. So if you have an existing concrete wall and you want to waterproof it or repair it, what you can do is basically you need to make it clean. You need to power wash it. You need to get it down to a CSP3, which is like an 80 grit sandpaper. And there's chips the Concrete Repair Institute has. You can buy the chips, and they'll tell you like what the feeling should be in the look. But really a power washer tends to do it with the concrete. So you clean the concrete with the power washer, and at the same time you are etching it to a CSP3 consistency. Then you want to get it to an SSD state, which is saturated surface dry. So you want to basically soak that wall, whatever you're repairing, until it can no longer take on water. Okay, so that typically takes a few hours of just wetting it. Once it's in the SSD state and it's been cleaned and roughened, you apply the crystalline. It comes in a powder, but you mix it with water to create a slurry coat, and then you can either brush it on, spray it on, trowel it, or roll it on with a paint roller. And what that does is allows the chemical that's in there to diffuse into the wall. So the suction really that you've created by cleaning the wall and opening up the pores and capillaries and soaking it in water, now that's all going to draw the chemical into the wall, and now it's in there for life. So the coating process is more just a way to get the chemical into the wall or into the structure, and it's not a barrier. Actually, after about 21 days, you can remove that coating, because we do a lot of swimming pools where they might want to tile over the concrete, after. And so if they repair the pool with the coating, after 21 days, once the chemical is in there and set, you can remove the coating and then tile over it, and the chemical is there for life. So
I gotcha. And there's, other products out there other than Xypex. If people are considering different crystalline products, what should they look out for to make sure they're getting something that, performs?
Great question. So there's a lot of performance-based testing out there that we often will have engineers specify certain performance tests so that they know they're getting, a product that's going to work the best and last. There's a couple out there. There's a DIN, the DIN 1048. It's a permeability test. It's basically like an 8x8 cube of concrete, and they apply about 167 foot-head of pressure to it through an apparatus, and they measure how much the water can penetrate into that cube. Okay, and so they have an untreated sample with no crystalline in it. Typically, the water will get in there about 3 inches deep into that block. And then actually with Xypex, if you use it, the average is about 1/4 inch only. So the water simply cannot penetrate that cube. So you can have other manufacturers run that test and see what kind of permeability they get through that test. So that's one of them. The other is the Army, probably the most popular one is the Army Corps of Engineers, CRD 48. the CRD C48 test. It's a similar test in that it's a cylinder of concrete and it's 6 inches deep, and they apply 405 foot head of pressure. So it's just an elevated, pressure, 405 foot head of pressure, water pressure. And so you stick this concrete sample in an apparatus, you apply the pressure, and you're looking to see if the water passes through. One thing that we've done is actually modify that test to be a 2-inch sample, because if you think about it, a lot of rebar and reinforcing steel is only going to be 2 inches from the surface when you have your concrete cover. Whereas in the standard Army Corps tests, the CRD C48, if you have a 6-inch sample and that water gets through 5 inches, you're still technically passing that test. Because what you need is the untreated sample to leak. So part of that test is you have a sample that's not treated with crystalline, just regular concrete. The water needs to leak through that sample, and then you take that same concrete mix, you put crystalline in it, and we need to stop the water now, and that's how you pass. But if the water gets through even 5 inches of that 6-inch sample, it's technically a pass. But to us, that's not really, because that's too much water intrusion in our eyes, right? You're bringing in sulfates, chlorides, you're going to corrode that reinforcing steel, and reinforcing steel will expand to 8 times its size, and that's how you get spalling, exposed steel, and then you get a whole other set of problems. So with us, we modify the test to be just 2 inches, and we make sure no water can pass through at 2 inches with 405 foot head of pressure. So that's one thing. You do the 2-inch modification test on that. Sulfate resistance testing. There's tests where you can put concrete into a solution of sulfate. We do one with 36,000 milligrams per liter of SO4 solution, one that's untreated, one that's treated, and you can measure kind of the corrosion over time of those samples. And we see 40 times less corrosion on that test when you use Xypex or crystalline. The most prevalent test to see between crystallines, what you're actually getting is the loss on ignition test. So you were asking, is this the ACI test? I actually looked up, it's ACI 3114, something like that, or 311. And there's also a DIN test as well that has the loss of ignition. But what you do is you take the product. So again, it's powder-based typically. You bake it in an oven at 1742 degrees. And whatever burns off in that oven is your active ingredient. That's the good stuff. That's what you're paying for. Whatever remains after that, after you put it in that oven, is just your filler. It's your cement or some sand. And so a good way to test between different crystallines is to do the loss on ignition test and see how much remains. So with Xypex, for example, we get about 50% burn off, or 50% of our product is active ingredient. You can run it with the competitors and see what they get. Typically a little less than that, but that's the one thing you can do. So there's various tests out there.
Yeah, I'm not finding the ACI. It looks like ASTM is working on something
ASTM,
currently.
that was it.
Yeah, they're working on something.
ASTM C114. Yeah.
It says it's not, I guess, approved yet, but it's in a list of the work items. There's a permeability reducing admixture for hydrostatic conditions, ACI 212.3, but it says it's a guidance, not a pass-fail standard.
Right. Yeah, I've also seen some ISO 29581 test, which is more of a loss on ignition, and then also a DIN, which is more of a EN European test 196-2. Which is a loss on ignition test as well. So a lot of different cement-based products will do the loss on ignition test just to check what's active and what's more the filler.
Right. On a commercial job, I think most of the folks that listen to the podcast are more familiar with a commercial project. Where is a Xypex typically used?
Yeah. So number one is going to be any kind of water plant, water treatment facility, just because they have so many water holding structures, and the water will, corrode that concrete over time. And now your city is left with a hefty maintenance bill. So the cities really typically will use crystalline in all their water and wastewater plants just to protect the concrete over time. It really reduces their cost of ownership and their maintenance over time. Reservoirs, dams, tunnels, foundations, underground parking garages, anywhere where the groundwater is an issue. We've even done some large slabs in data centers where they have corrosive soils, and just to prevent anything from getting up into through the concrete, they actually put Xypex in the entire slab to prevent that. A little less common in slabs, but a lot of underground foundations. Actually, you mentioned elevator pits. We started doing elevator pits in the in the 70s when the product first came out. It kind of got us start in elevator pits, but it's since moved on to other foundation elements, marine structures, and then, water, wastewater facilities, tunnels, and reservoirs. Anywhere you're trying to keep water out, really, or keep it in, is a good use for Xypex.
Before you decide that you're going to add a crystalline to the concrete, is there something you need to consider? Is there a water cement ratio that needs to be in between? Is there workability issues that you need to keep in mind? What's things like that you need to consider before just saying I'm going to put some crystalline in my concrete?
Yeah, no, good question. A lot of people ask those kind of questions. Obviously, they're concerned about the finish. Luckily, Xypex has been around almost 60 years. It doesn't interact with any other admixtures, no negative effects. It doesn't affect your slump, your finishing, your bleed water, anything like that. So it really has little to no effect on the mix itself, which is nice. You're really only adding a 1% dosage of your cementitious material. So let's say you have a 600-pound cement mix. We're going to count fly ash, silica fume, all the cementitious materials that you might add. We're going to count those typically, but 1%. So you're looking at, maybe 5 to 7 pounds that you're adding per cubic yard. So it's quite a small dose. Xypex is all mineral based, so it really doesn't affect slump or workability, anything like that. So that's good. And we're using over 100 countries. I've never seen an adverse effect with any other admixture either. So it's kind of great to have that. And yeah.
I've had some, let's say, challenging owner representatives when I was in operations and I oversaw projects. So I haven't run across this scenario, but I'm just thinking if we had crystalline waterproofing on a job, I could see one of these guys asking it. First of all, is there a cure time when this stuff is like you can say it's activated, or does it? You were saying that ironically needs water to actually be activated, which you're trying to prevent water from getting in the concrete. Yeah, right. So that's kind of funny.
Yeah.
So is there a certain cure time? Like if you're doing an elevator pit, is there a period of time where you say, hey, the Xypex is in there, but it's not, or it's in there, but it hasn't started doing its thing yet? Or it just needs to have the water at some point after the concrete is cured after, say 7 days. Does a 7-day cure, it's in there and it's ready to go? Is that
So typically, if you use it as an admix, the crystals will start growing immediately because, there's water present. Now, once it gets introduced to hydrostatic pressure, so say you do an above ground tank, you pour the concrete, the crystallines in there, crystals start to form by the little amount of water that's present, in the mix already. Then you fill the tank. You might actually see some leaks at that point on day one. So the unique thing about crystalline versus like a membrane or a liner, the strongest point of a membrane or a liner or a coating system, a traditional system, is day one. Those just get weaker over time. They need to be replaced. With crystalline, it's the reverse. The weakest it'll ever be is day one. Okay, so you fill that tank, say there's a hairline crack somewhere, and we say we can heal 0.5 millimeter cracks, so 0.5 millimeters within 2 to 2.5 weeks. Okay, and that's under hydrostatic pressure. And so we have several instances where they might fill a tank and you have either some cold joints or some hairline cracks, and you'll see some water getting through, and then they'll come back 2 weeks later, and those cracks will have healed. And so it takes a little bit of time for that crystalline to grow and block the water. But once it does, that's it. And then it's sealed up. And then the great thing about it is the chemical is in that concrete. And so if another crack occurs somewhere down the line, 3 years later, and water gets into that crack and is leaking a little bit, if you wait 2 weeks, that crack will seal up as well. So it's kind of like Roman concrete where it heals itself and yeah.
Allegedly.
Yeah, right. Yeah.
So you beat me to the punch. So they when you do, like, you were just saying, a leak test. So if someone has a job that has a crystalline in it and they do the leak test and that thing leaks the initial test, you're saying that's a good thing. It leaks, and then once you do that test again, that there shouldn't be a leak at that spot again because the crystalline has been activated.
Yeah. So, I mean, as soon as water hits it, it'll be activated and it'll start to grow. It just takes time for the crystals to grow and to actually block the water intrusion, especially under hydrostatic pressure. So, yeah, about 2.5 weeks is what we published at. If you get a crack up to 0.5 millimeter wide, which is about the thickness of a credit card. So if you can fit your, credit card in there, it's maybe a little too wide. And then that's a whole nother story. We have repair products to repair cracks and all that stuff. But if it's a hairline crack, the water will get in there, the crystalline will be activated, and it takes about 2.5 weeks for that crystalline to grow enough to block the water. So, yeah.
Okay. So would best practice be to fill that tank, let it sit there for 2.5 weeks,
typically,
and then drain the tank and then do it again? Is that?
They would typically just keep it filled. Let the crystalline do its thing, and then it would just stop leaking. And it's not like it's gushing out water or anything. Typically with a hairline, it's a small leak, so they can typically keep it filled, and then over time, up 2.5 weeks, maybe less, that crack will heal and stop leaking. So yeah, we typically keep the tank filled at that point.
All right, put that in your schedule. Make sure you guys got that in your schedule if you got this stuff. If you got to do leak tests. But I guess that's better than having to do if you got cracks. I think every one of those jobs where you have a concrete structure that's holding water, you got to have some money in there to do some crack repair because concrete cracks, and so that's the first time I've heard of that approach. But again, I haven't done a lot of water or wastewater work, so
yeah.
Is that
on the flip side? If they do a traditional system, they typically have to wait 28 days for the concrete to fully cure before they install, a membrane or a liner or a coating.
Right.
So overall schedule is typically reduced. They can use it, in the admix, it'll start kind of growing right away. And then when they introduce the hydrostatic pressure, it'll just accelerate that growth over time.
Yeah. That's where I've seen it before, is where they're like, hey, we're going to put, they don't say crystalline waterproofing. They say Xypex. Hey, we want to get rid of the waterproofing guy, so he's not messing around with the elevator pit. We want to Xypex this, and then you tell him how much it costs, because in my experience, it's not cheap. You got what you guys sell it to the ready mix guy, and then the ready mix guy marks it up and he's making some money on it, and then we mark it up and then tell the GC, hey, this is the cost, and they're like, well, maybe we'll go ahead and put that waterproofing membrane, but I haven't seen it in a while. But we're getting near the end of the episode here. Is there one thing that you want folks to remember from our talk today?
Yeah, just to consider, crystalline as an alternative to your traditional membranes and coatings, and due to the labor savings, you're typically going to say, the product's expensive per cubic yard, but if you compare it to the labor and the time it takes to do the coatings and the liners, and even that they're not permanent, you have to replace them. You have to, and if you backfill, then you have to excavate just to repair a lining. So I would say think about the long-term cost benefits of crystalline and the maintenance reduction. And then also just that, not all crystallines are created equal, and to look at some performance-based testing and specifications is often done. And, when I did fiber, that was huge. Performance-based testing can really get down to which fiber's performing compared to another one. So same thing with crystalline. You want to really look at those performance-based tests. But yeah, if anyone has further questions, they could reach out to me. I'd be happy to help. So.
Yeah, you beat me to it again, Nick. What's the best way folks to reach out to you? What's your preferred way?
I would say, email would be great. So it's just my name, Nick.Karam at Xypex.com. So quite simple. You can email me. I'd be happy to talk on the phone as well. Number's 216-956-1105. If anyone wants to give me a call, but email or phone call would be great. And thanks again for having me on. I enjoyed it.
Great. Yeah, no, I appreciate you coming on. Yeah, definitely reach out to Nick. Nick will have his own page on the website. We'll have a link to that, and I'll have all of his contact information for y'all to reach out to him and reach out to him and learn more about Xypex. Nick, thanks for coming on the show today. Appreciate it.
Thank you, Seth. Go Buckeyes.
Yeah, go Buck. Yeah, you see my thing up there, don't you?
I see it.
Yeah, that's my wife added. She's like, you need more stuff in your background. all the national championships for the Buckeyes back there.
Heck yeah.
All right, folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives. Dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. The color of our collars ain't white or blue. We're all gray collar through and through. Expect more, it's written in our blood.